not b squared, b plus 6, b plus 7. Now you set the variable terms with a variable in it, terms equal to 0. So for
Okay.
example, b plus 6 equal to 0 and b plus 7 equal to 0.
Okay.
And your final answer here is b
Negative
equals
6, 7.
yes.
And negative 6, negative 7.
Good. All right, now, I mean, just looking this over, we probably will get through all of it, but you may want to pick and choose problems that, like, if you maybe see one, say, oh, I know how to do that one. Like 22, maybe you already know how to do. It's up to you. We can just go in order. What do you think here? What would be best to help you today?
Probably work over all of them, I guess.
Okay. All right. All right. So just like the last problem, you do want to get everything on one side of the equation. So even though maybe you say, oh, I already know the answer, still want you to do that because we're identifying the type of factoring.
Do you
Identifying
need factoring at this point?
Well, I would recommend that because it's very easy to miss an answer. And if you remember that this is difference of squares, you will not miss an answer.
It'll be v minus 1, v plus 1. Yeah,
Yes.
so but could you also do the square root method there and you'd still get v equals plus or minus 1?
Yes. And the reason though I recommend this is that you're not the kind of student to forget, but some will. Some will say, oh, they'll just write v equals 1 and they'll get 5 out of 10 on the test on that one, and they're wondering why. That's because you missed an entire solution. So
Yeah, no, that makes sense.
all right. 23 here. All right, 23. Again, you want to get everything on one side, and sometimes you're not sure which way to move it. You generally want the x squared term to be positive. That's usually good guidance. In this case, you would move the 2x to the right. So it's 4x squared minus 2x minus 22. If you leave 0 on the left, I would recommend moving it to the right, just to make it more what you're used to.
Okay.
And then always look for a GCF.
Okay.
What is the GCF here?
2.
2. So we got a 2x squared minus x minus 11 equals 0.
Okay.
All right. Now, this is not 1. It's a potential grouping, but we're going to see here that it doesn't work out. So 2 times negative 11 is negative 22. You're looking for two numbers that multiply to negative 22, but add to, negative 1. And negative 22 has a limited number of factors.
Yeah.
Do any of these add up to negative 1?
No.
No. So here's your alternative: quadratic formula or completing the square. Do you have a preference?
Probably quadratic formula would be actually completing a square would be easier.
Okay, let's go back to, we've got to go back to this line to complete the square.
Yeah, so you get 4x squared minus 2x equals 22. Divide by 4, so you can get 4x squared minus 1/2 x.
Now you got to be careful here. The way you're doing this is fine. This will work, but you're dividing even this number here by 4.
Yep.
This unknown number, which we have to account for later on. And you're dividing this by 4, so it's 22 over 4.
Yeah.
I don't show it this way, but this will work. It becomes x minus 1/4 squared.
Yep.
And this is 1 over 16.
And that divided by 4, 1/4.
Try again. This is the problem here. It's because oh, I'm sorry. So this is where
it's like a 1/58, 68.
Well, so here's where I would here's how I would do it if you're gonna do it this way. And I did not show it to you this way. So if you got this another place, that's fine. What you can do here, how's the best way to do this? All the lines have to be equivalent. So yeah, like this is 1/4 here because you are dividing it by 4. So I guess you do have to kind of do it this way.
Okay.
And then you got to make a common denominator over here on the right.
Okay. So then you get 89. That doesn't work out very nicely.
Well, we know it wasn't going to because it's quadratic formula or completing the square. They never work out nicely in that, or they typically don't because you wouldn't use them otherwise. So yeah, it's 89 over 16. You got to take the square root of both sides.
Okay.
So x minus 1/4 equals plus or minus the square root of 89 over 16.
Okay.
X equals 1/4 plus or minus the square root of 89 over 4.
Okay.
And there you have it.
Okay.
Okay. If you are going to divide by 4, it's actually better to go to this line to complete the square. Like if you're going to
Right.
divide by that leading one, this gets really confusing, which I don't show it that way, because then
Okay.
you're adding the same number to both sides. But maybe we won't see that again. Just something to think about here. All right, 24. All right, so we're going to move that 7. Probably move that 7 over. I mean, what you really hope for is that it's a problem where you can factor using, two numbers that multiply to the last one but add up to the middle one.
All right.
This one I don't think works. And that's where you like you start saying, well, maybe I should just use quadratic formula every time or just complete the square every time. And you might be right here. I'm just going to check this one to see how it solves. Yeah, so your better option here is either quadratic formula or completing the square.
I should probably quadratic formula then, because I've heard that's easier.
Well, you've been doing really well with completing the square. This one, completing the square, is pretty quick. Let me show you that here. It's x plus 9 squared, and then plus 81 plus 81. So that becomes 149.
Okay.
And you take the square root of both sides. So x plus 9 equals plus or minus the square root of 149. And then you subtract 9. So
All right.
x equals minus 9 plus or minus the square root of 149. So completing the square is generally faster than quadratic formula,
Okay.
but you have to be really solid with it. Like you can't make any mistakes. Quadratic formula always works, but it's slow. Probably think of some things in life that are like that where, but you always hope that you can factor, like meaning it's an a equals 1 or a grouping or perfect square trinomial. Like you really want it to be one of those because it's like last case, really don't want to use completing the square quadratic formula if you don't have to. Again, got to get everything on one side here.
All right.
This one can be done by factoring. Will you give that a try, please? And I'm going to just step away for 10 seconds to move the chair. Be right back.
Okay.
So two numbers that multiply to minus 14, but add to minus 5.
Okay. x minus x minus 7 and x plus 2.
Yes,
Okay.
very good. So go ahead and set those equal to 0.
And x equals 7 and x equals -2.
You got it. All right, 26.
Okay.
So so a couple of things here. Do you see how the leading term is negative?
Yeah, you don't want that,
You
right?
don't want that, but here's the thing, since they're all negative and they're all divisible by -3, you will be factoring that out. So you don't necessarily need to move it, but you could move everything to the other side. Maybe the thing that I don't like here that I'd really would recommend that you do is reorder it in descending order. And then factoring out the -3 from everything.
Okay.
All right. But this one does not factor, which means you have to go back to something else here to solve this, either quadratic formula or completing the square.
Okay.
Your
So
choice.
then I kind of want to try the quadratic formula.
Okay. So the nice thing is you can use quadratic formula in just this part. You don't have to account for
The -3.
yeah. So it's A equals 1, B equals 8, and C equals 6.
So my x equals -b plus minus the square root of b minus 4ac
B
over
squared.
2a.
B
Oh,
squared
b
minus,
squared.
yeah,
Okay.
yeah, very
So then
important.
x equals -8 plus or minus the square root of 64 minus 4 times, or minus 4 times 6 over 2. X equals -8 plus or minus.
Wait, no, wait, oh, I messed up here. I'm so sorry. This is 16.
Oh, okay.
I was really surprised that this didn't work out. So this is a perfect square trinomial. We'll get to
Oh,
quadratic
so it'd
formula.
be x plus 4, x minus 4. No, x plus 4, x plus 4.
Yes.
So then it'd be plus or minus 4, right?
Well, you're kind of mixing the two formats. This is what you're setting equal to 0, the x plus 4,
Yeah.
not the x minus 4. There is no x minus 4.
Oh, so it'd be just -4. That's the only possible answer.
Yes. All right. Let's keep going here.
Okay.
The other thing that teachers do here is they give you a bunch of problems and then they give you one that's maybe looks like it's okay, but it's not. If we add 20 to both sides, this is n squared plus 10 equals 0.
That doesn't work.
This is considered prime, meaning no solutions in the real domain. There are complex solutions.
So
You
it'd
got
be n equals the square root of 10.
this plus or minus the square root of -10.
Oh,
Have you talked about what I equals?
no, it's an imaginary number.
Yes, it's so I is the square root of -1. That's how you present your answer here. It's plus or minus square root of -1 times 10, square root of -1, square root of 10. You have to break it apart like that. And then it's plus or
We've so far
minus.
just been putting it as no real solution, like NRS.
Okay. Yeah, then do that. No solution, no real solution.
Okay.
All right. I want to say 35 can be Well, actually, I'm not sure. Let's take a look. 28, sorry,
35?
28, sorry, it has a 35 and I was looking at. So this is x squared minus 12x minus 35 equals 0. What do you see here?
Um, 35 doesn't have a square root. Probably solved by the completing the square.
Completing the square or quadratic formula. This one would maybe be worth considering just to try it out if you wanted.
I think probably completing the square would be easier though, right?
It is.
Yeah,
Yes.
so then
If
probably
you're
completing the
comfortable.
square. Squared minus 12x equals 35. So then that's x plus 6, x minus 6 squared equals 35 plus 36. X minus 6 squared equals 71. X equals 6 plus minus square root of 71. X equals 6 plus minus square root of 71.
Yes. That's good. Yeah.
Oh, and then it says it wants the simplified answer too. So then,
This is the simplified answer. 71 is prime. There's no reducing it.
oh, it says all answers should be exact and simplified. Oh, that doesn't mean I have to give a decimal. That just means it can't be. It has to be in.
This is exact. If it could be simplified, I would tell you. Like we've been doing that all along. Trying to look at one here. Like this is also prime,
Yeah.
so
No,
there's nothing
okay.
to do.
I thought it meant. Oh, because approximate answers is.
The calculator is not exact. The calculator is always an approximation.
Yeah.
All right, go ahead and try this one on your own. It does kind of work out nicely.
Okay. So then. Wait. And so then.
How are you doing on this one?
Good, I think. Almost done. So I got n plus 9/2 equals plus or minus 1/2. So then I got n equals 5 and n equals 4.
Yes, but it doesn't sound like, well, just gonna guess here. It doesn't sound like you just did a traditional factoring on this.
No, I did completing the square.
Okay, so you went the what I call the long cut. You gotta look for the ones that are better.
Oh, okay.
It's on the test. If you do it the hard way, even if you get the right answer, you're gonna wish you had saved the time by doing it the other way.
I got just normal 5 and 4.
It's you can see here that two numbers that multiply to 20 to add to 9 plus 4 plus 5. So you set them equal to 0 and get -4, -5.
Okay.
If you did want to complete the square, which we can do, it becomes n plus 9 over 2 squared. And then this becomes 81 over 4. And then it's minus 80 over 4 plus 81 over 4, which is 1 over 4. You have to take the square root of both sides. So it becomes plus or minus the square root of 1/4, which is plus or minus 1/2. You just see by the volume of work here, this is not the right way to go, but it's minus 9/2 plus 1/2 minus 9/2 minus 1/2. Maybe you just had a sign error somewhere.
I probably did have a sign error, yeah. That must have been what it was.
Completing the square and quadratic formula should be a last resort. You really don't want to use them as your starting points.
Okay.
Okay, so here's number 30. 8r squared plus 12r minus 21 equals 0. This one does not factor. So there's no grouping. I checked into it. Why don't you try quadratic formula on this one? Unless you really want to do completing the square.
Okay.
I don't like it because 8 doesn't really go into 12. You're gonna have fractions all over the place.
Okay. So I'm solving this on my own.
It's up to you. I mean, I can help here. I mean, A is 8, B is 12, C is minus 21. The biggest issue when completing the square is getting the part under the root correct. That's usually where I start with students. I say, okay, let's get the discriminant right. Let's see if we've got that value under the root the same.
Okay. So then you would end up getting I'm having like a brain fart right now.
12 squared minus 4 times 8 times minus 21.
Yep. So then 8 times 21 is 100 negative 168. And then that has to be minus 4. Multiply that by negative 4. Let me get my calculator. Negative 4 times negative 168. So negative 672.
We got different numbers here. 12 squared is 144. 4 times 8 times 21. I don't know what that is. I did the whole calculation together, so I'll do that next. That's minus 672, so it ends up being plus 672.
Okay.
So it ends up being 816.
Okay.
So one of the main problems with quadratic formula is that you typically have to reduce a root. Whereas
Alright.
completing the square, sometimes it works out a little better and there is no reduce. But this one could be, could be a little bit bad. You got to make a factor tree here. And depending on how fast you are doing this, it can really eat up your time on an exam.
Yeah.
So that looks to be it. 17 is, or 51 is 3 and 17. Looks like there's 2 pairs. Just double check this, make sure that's right. Yeah, that is right. So it becomes 2 times 2 square root of 51, 4 square root 51, minus 12 plus or minus 4 square root of 51 over 16. But wait, there's more. You have to divide both by the 16, which ends up getting minus 12 over 16 plus or minus 4 over 16 square root of 51. Then you reduce.
So there's basically just a butt ton of work involved if you do quadratic formula.
Yes. All right, so we for sure are not going to get through all of this. Are you sure you don't want to pick out some questions or just keep going in order?
The word problems.
So the word problems you said you already worked through. I only see 19 and 20.
Oh, there should be. Oh, did I not send you a picture of the back page?
Yeah, I didn't get that. Oh wait, I'm sorry. The 41.
41 and 42. Yeah.
Okay, let's go to those and then we'll come back and do more of these if we need to. All right, the length of a rectangle is 1 meter more than twice the width. So it's always good to draw a picture. The length is down here at the bottom. We'll call this W. The length of the rectangle is 1 meter more than twice the width. Twice the width is 2W. 1 meter more is +1. If you can't write the equation, you cannot proceed. Always good to spend some time, double checking that it's correct.
Okay.
All right, now the area of the rectangle, the area is length times width or base times height. And the area is 55, but it's 2W plus 1 times W, and that equals 55.
Okay, so 2W. So that's 2W squared plus W equals 55.
And then you move the 55 over. So what you're looking for here are two numbers that multiply to -55, but I'm sorry, I take that back. You have to do the 2 times the -55.
Yeah, so you need to get -110. So it's to add the -1, there has to add to 1, multiply -110.
Yeah.
And that's
So
actually it's easy. So it's 11 and 10.
which one's positive, which one's negative?
Positive is 11, negative is 10.
Okay. So this is 2W squared minus 10W plus 11W minus 55 equals 0. This is a factor by grouping.
Okay, so then you factor out, so you get 2W, and then you get on the inside W minus 5. Then you get W minus 5. And then you put 11 on the outside, so it's 2W minus 11.
Plus 11. Plus
Oh yeah,
11.
plus 11, sorry. And then W minus 5. Then you get W equals 5 and minus 11 divided by 2. And the other one is insignificant because it doesn't work.
It's called better math word here would be extraneous.
Yeah.
If you want to be mathy.
Okay.
Or it does not, it's outside the domain. Now we are not done. We have just found W. What does it ask for?
The dimensions of the rectangle. So do I have to plug in W?
Yes, you cannot say W is 5 and expect to get full credit. You have
So
to
you
say
get
the width
11 and
is
5.
the width is 5 and the length is 11, and you need units.
Yeah. I wonder if you could have figured that out, because I don't think 55 in it has any other factors. I think it's just 5 and 11.
That
I
is
wonder if
correct.
you-
Yeah, you can, but you likely had to show your work here.
yeah, but I just wonder if you could have done it.
Yes, the answer is yes. Yes. Usually when the
Okay.
answer is nice, there is that thought like, well, maybe I could have figured it out without doing all this stuff. Usually there is. All right, the value of a bank account is given by the function a of t equals minus 3t squared plus 50t plus 75, where a is the amount in the bank, t is the time in years. When will the value of the bank account be at a maximum?
Can I substitute 0 for A of t?
Yes, but here's the graph of it. Just show you the graph. This is time, and this is the money in the account, and it looks like this. So are you interested in point 1, point
Point
2,
1.
or point 3? Yes. So point 1 has nothing to do with factoring.
Oh, point 1, you have to put it in vertex form.
You can also use formulas. So if you're going to put it in vertex form, which is fine, that will work.
You just have to like factor it or like a. No, you do like you do the completing the square and then
Yes. Yes. I would not complete the square on this one. This one's really hard. There's formulas here though, minus b over 2a. Are you guys allowed to use that?
Yep, negative b over, so that'd be negative 50 over negative 6.
Okay, but that's just the t value. That's, you got to put that back into the original to get the where it occurs.
Let me get my calculator. And calculator. So minus 3 times parentheses 50 divided by 6. So it's just 8.333 plus 50 times 50 divided by 6. That's not doing anything. Okay. Negative 3 times 50 divided by 6. Negative 25. Yeah.
Let me know when you got a final answer.
Okay. I got 699.6667.
I got a different result here. Let's check to make sure I did it right.
I
We
may
got
have plugged it
the,
into
we
my
got
calculator.
the same t value, right?
Yeah.
So the issue is probably just a sign error with, or not a sign error, just a computational error, squaring before you multiply. The answer I've got here is $283.33.
Okay. That is not this. Not what I got.
Always good to do the calculation twice. Maybe try it one more time.
Oh, maybe I didn't put parentheses around my. Maybe it didn't register the negative 3, so 8.33 times 8.33 times negative 3. Yeah, that's weird. So I'm doing it on my calculator on my phone. It's 8.33.
It's really hard to use your phone for this. It's not a scientific calculator, so it doesn't, you have to know to do you have to do the 8.33 squared first, then multiply by -3, and then you got to hold that number somewhere. Then you have to take 50 times 8.33, and then combine those two numbers, then you can add the 75.
Let me see if I can find my scientific calculator first. Here it is. Negative 3 times 8.33 squared plus 50 times 8.33 plus. Yeah, now I got the same result you did.
Okay. All right, so we got some time left here. Do you want us to just go back where we left off, or do you have some problems you want us to look at specifically?
There was no, there's really anything
right.
more specifically.
We'll go back to 31.
Okay.
All right, so we want to move everything to one side. Let's move everything left because that's going to get the leading term positive. Maybe we'll see something if we do that. So it's 6a squared minus 36a. And notice that when you subtract 8 from both sides, it goes away.
Okay, and
This
that
is-
equals 0.
This is a GCF. Whenever you see all terms with a variable, it's a GCF.
And A. So 6 principally, or 6, I can actually factorize that. 6a minus 6.
Good.
And then equals 0. Oh, that's it. No, because those are both.
Set them both equal to 0 and
Yep. So a equals 0 and then a equals 6.
you got it. All right, 32, kind of same scenario, probably good to move everything to one side. Maybe to see it here. So if we add 4 to both sides, it's when I'm gonna rearrange this, 100x squared minus 1 equals 0. This is difference of squares, but you can also use the square root method. If you're going to use the square root method, then it's the one exception where you move everything to the other side. So I kind of heard you wanted to do that earlier. You just have to remember it's plus or minus when you get your solutions.
Okay. And 1/10, right?
Plus or minus.
Yep.
Cannot forget them both. You will definitely get dinged. I mean, I see the style here. The style of your instructor is they're going to give you some that actually look hard, very difficult, but they're not. And then they're going to be the ones that kind of look like they work out, and then they end up being awful quadratic formula completing the square.
Okay.
Very sinister from an educational perspective. So again, probably best to move everything over to one side of the equation and then make an assessment about what it is that it may be. This falls into the category of potentially looking really difficult, but actually not being that difficult. Because once you get it over, it's positive n squared. That's always good when the leading coefficient is 1. So now, are there 2 numbers that multiply to minus 32 but add to 8?
Trying to think of factors for minus 32. So you have like 2 and 16.
Yep. And then 4 and 8. That's it.
Yeah.
So
I don't think so.
none of those work. So your choices then become quadratic formula or completing the square.
Completing the squares always sounds easier than quadratic formula.
I would complete the square. All else being equal, I would complete the square. I mean, it depends if that middle number can be nicely halved.
Okay, so it can.
It can. So that's why you would consider doing it.
Okay, so n plus 4 squared equals 48. So it's plus 16. And n plus 4 equals square root or plus. So n equals -4 plus minus square root of 48, which means n equals -4 times.
Plus minus, -4 plus minus.
Yeah, plus
you do-
minus.
you
And
do
then
have
there's stuff you can do with it. So it's like 4 square root of 6.
Very good. It's best to go with 2 as the smallest prime number and then just keep using it until you run out of numbers that it works with. You can see that there's a pair of 2s that come out. Is that clear? Every pair you
Yeah, every pair you have to, it's because it's like because you multiply them together and you get square root.
yes. All right, so that's it for that one. Any questions, thoughts on that?
No, not
Okay.
for me.
We'll just keep going here. All right, so again, probably just best to move everything left. See if, is that an A? Looks like an A. So we're adding 23A. And we're adding 2. So we got minus 20 equals 0. This looks pretty bad. You always try 7 times minus 20. First time's the last. And then maybe there's 2 numbers that multiply to 23. I don't think this one works, but maybe take a quick look at that.
It doesn't sound like it's gonna work.
Well, the reason that you want to try is if it does work, you will have wasted a lot of time using quadratic formula for something that does work. This one does not work. Boy, this one's horrible. Did I do this? Is this right? 7a squared plus 23a minus 20. Wow. Oh no, I take that back. This one does factor. Okay. So this one does work. So this is where you got to do all the factors. 1 and 140, 2 and 70, 3 and 3 does not work. 4 works though, 4 and 35. So notice we're looking for them to be 23 apart. 5 works, 5 is 28, and there it is.
Okay, so 5 and 28.
So we're going to go with positive 28, negative 5. So 7a squared plus 28a minus 5a minus 20 equals 0. Why don't you try working it out from here?
Okay, so then 7a, so a plus 4, a plus 4, and then that's negative 5. 7a minus 5, a plus 4, so a equals negative 4, a equals plus 5, 5, 7. So I got a equals negative 4 and a equals 5, 7.
You are correct. Very good. All right, so we're going to go ahead and stop here for tonight. Good job. Definitely a lot of factoring practice, that's for sure.